To continue on with 3.2, go ahead and solve out this bell problem. When you solve it out, you should get a solution of 1/2 for x and 5/2 for y. Again, don't forget to write it as an ordered pair. Again, that was 1/2 and 5/2. We're still continuing on with solving the equations algebraically. The next method is elimination. This one's a little more complicated, but I like it better. For step 1, you multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. Add the revised equations from step 1, combining like terms, will eliminate one of the variables and solve for the remaining variable. Step 3, substitute the value obtained in step 2 into either of the original equations and solve for the other variable. So for our first system, solving by elimination, I first look to see, looking at our x values and our y values to see if any of them are factors of each other. So I see that 3 and 6, if I multiplied 3 by a number, I could get 6. So I'm going to multiply this whole equation by that number. So 3 times what gives me 6, which is 2. But if I do that, notice how our x variables wouldn't eliminate. Since one is positive, I need to make the other one negative. And when I multiply this equation by -2, I multiply the entire equation by -2. So 3x times -2 is -6x. -2 times -7y is plus 14y. And 10 times -2 is -20. Our next step is to add up our two systems. So we add them up here. And we combine like terms. So we look at our x variables. 6 plus a -6, they eliminate, which was our goal. -8 plus 14 is 6y. And that equals 8 minus 20, which is -12. And then we solve this out for y. So we divide both sides by 6. And we get y equals -2. So we have our y variable solved for. Now we just need to plug it back in to find x. Again, it doesn't matter which equation you use. I'm going to plug it back into the first one. So we have 3x. And I'm going to multiply my two numbers together. So -7 times -2 is plus 14. And that equals 10. Again, remember you put it back into the original equation. Then we have to get x by itself, so we subtract 14 to both sides. So we get 3x equals -4, and then we divide both sides by 3, so we get x equals -4/3. So our solution is -4/3, -2. So that is our solution. So you go ahead, figure out which variable to eliminate, and eliminate it. Come back and we'll talk about your solution. So my suggestion would be is to eliminate y by multiplying our first equation by 3, because 3 times 3 gives us 9, and we already have a negative, so we don't have to multiply by negative. So that means we'll eliminate our y and solve for x, which we get -3. Plug it back in, we get -2. So our solution is -3, -2. Our next system, notice how our x variables are already opposite signs, same numbers, so we don't have to do anything, just add up our two equations. Eliminating x, so we get y equals 5. When we plug it back into the original equation, we get -1/4 for x, so our solution is -1/4 and 5. This next example, we have, notice how we can't multiply two by some number and get 3, or 7 by some number and get 5, so we have to multiply both equations by this opposite number. I'm going to eliminate x's first since those are smaller numbers. So again, we have to multiply both equations. And we multiply by opposite numbers. So 2, we multiply this by 3, and this one by 2. But since they're both positive, I'm just going to multiply this one by negative 2. And once you do that, remember to distribute all those numbers through, negative 2 to all those terms. Add up your two equations, do the same thing like you did before. Eliminating our x, we should get y equals 2. And then when we plug it back in, we should get x equals negative 5. So our solution is negative 5, 2. These next two examples we have to solve. So go ahead and eliminate one of our variables. If you notice, we would multiply our top equation by negative 3, which would give us negative 3x plus 6y, and that equals negative 12. When we add up these two equations, notice how our x's cancel and our y's cancel. We're left with 0 equals negative 4. Now, is that true? No. So our answer is no solution. Next, again, notice how we have no number that multiplies 4 times what gives us 14, or 10 times what gives us 35. So multiply both equations by the opposite number. So I'd multiply the top one by 14 and the bottom one by 4. And when we do that, we get 56x minus 140y equals 112, and negative 56x plus 140y equals negative 112. Notice how all those numbers are opposite signs, so they'll all eliminate. So we get 0 equals 0, which means we have a solution of all real numbers. Or you can write that as, write 2 lines and make it an R. So we have now finished 3.2, solving systems algebraically. This will be what we're working on tomorrow in class.